To do the simulation of voltage control frequency shifter. Now these two are the operational amplifiers and these three 10 kilo ohm resistors. This is the 10 volt voltage source that is given to negative terminal. This is the main voltage which is controlled the output frequency, that is E, right? So for initially I will give 0 volts, right? Now see, this C1 is RE, so I have given 1 kilo ohm, C1 1 microfarad. If you change this RE and C, we'll see what is the changes occur. This one is the NA555C trigger is connected to capacitor as well as see threshold and discharge terminal, and VCC pin is connected to plus 5 volt, ground is connected to ground. So generally we can left open the control voltage, or we can use 0.01 microfarad to the ground, so no problem, right? Now we'll see the simulation. So this is a transient analysis, so I have given 10 millisecond is the simulation length. If you see the output, see this is the one square wave square wave waveform is generated, right? So this is some different frequency will be there, but we don't require that frequency. We'll see if you change the E. This is the generally we say for center frequency of oscillation. If you change this E, suppose I have changed it to 4 volts, right? Is the frequency is increased or decreased? See, the time period or the pulse width is decreased, right? If this is not clearly visible, I will go for 5 millisecond time simulation length. See, so this is at 4 volts. If you see at 0 volt, see the time period or pulse width is increased. So pulse width is increased means frequency is decreased. So it is at 0 volt. If you change this to 5 volt, see how it will see the pulse width is decreased, that means frequency is increasing, right? So this is one observation we have to make, and one more is across the capacitor what is the voltages. Now if you see the voltages, see this is, see 1 by third VCC, that is 1.66, so it is increased to 2 by third VCC. Now the moment it is greater than 2 by third VCC, it is falling in the within no time, that is 0 time constant, right? So this is the capacitor voltage. So how to change this capacitance voltage is, if I change this RE, suppose I increase it to 3 kilo ohm. Now see the it is time constant is increased, that is the one, right? RE into C is increasing means time constant is increasing. If we can increase by changing the capacitor as 5 micro, if you run again, see the time constant is very much high, right? So by these two parameters also you can increase or decrease the time constant. If you see the output, see that is the output, so very low frequency or very high pulse width it is generating. So this is how a voltage controlled oscillator or voltage controlled frequency shifter, that is this E is controlled the output frequency. Now what about this 10 volt is, it is designed for this current actually. Now if you change this voltage to 8 volts, if you run again, if you see the capacitance voltage, see it is simply constant, so it will not generate any the triangular waveforms. If you increase it to 9 volts, so what will happen, we'll see. So now it is generating a control voltage or at capacitor voltage. So it is, we have to take some optimized voltage here. So that is they have taken 10 volt, so you can generate a waveform like this. So how to change the what you call time constant, we have to change the RE. So if I taken 1 kilo ohm again, see time constant is reduced, right? So that is how the voltage control frequency shifter works. So if you change the input voltage, DC voltage, the output frequency is changing, right?